So this is lesson 9.7, and this is intermediate algebra, and we are going to get into complex numbers. Alright, complex number. I'm not going to go into a lot of detail with you because if you go on with math, you're going to get into algebra 2 and college algebra and calculus, and you'll be doing this more and more and more, and they'll just review it over and over and over. So I'm just going to hit the basics. Sometimes we might get for an answer or a number the square root of negative 16. What number times itself gives me 16? 4. What number times itself gives me negative 16? There isn't one because anytime we multiply two numbers together, like negative 4 times negative 4, two negatives give you a positive 16. There's no way to get a negative 16 unless I do this. But then those two numbers aren't the same. One's a negative, one's a positive. So how do you get a negative 16? How do you get the answer for that? What we come up with is called a complex number, or what we call in math an imaginary number. And a lot of students going, oh my gosh, real numbers are hard enough, and now you're giving us numbers that are pretend. They're really, really easy, and I think you'll enjoy doing them. So here's the trick. Whenever you have a square root with a negative in it, the negative you turn into the letter I and pull it out. And then that becomes, what's the square root of 16? 4i. So the square root of negative 16 is 4i. The I represents the negative, and the 4 is the square root of 16. And that is pretty much as hard as it's going to get. Okay, it's remembering that. Alright, so what if, let's do some things in here. I have the square root of negative 25. Well, that should be easy because you take the square root of 25 and you get 5, and the negative turns into an I, and you're done. Square root of negative 49. Square root of 49 is 7. The negative turns into an I. Square root of negative 12. Well, first of all, we have to take the 12 and write it as 2 squared times 3. And we still have the negative in there, but let's just pull the negative out and just put an I out there. And then if you remember, because the index here is 2 and that's a 2, 2 goes into 2 one time. So the 1, 2 comes out with nothing left over. 3 has no radical on it, so it doesn't come out. We can't do anything with it ever. And then the I is there at the end. So 2 square root of 3i, or you can write it as 2i square root of 3. That's a little bit more accurate. Square root of negative 17. Do you know what square root of 17 is? No, you don't, because there isn't one. So we just pull out an I, and 17 stays in there. Okay? Sometimes you're going to get powers. Sometimes you're going to get, when you do a problem, maybe you're going to multiply I times I, and you get I squared. Well, what does I squared equal to? And put this in your notes. I squared is equal to negative 1. First of all, let me make a little bit of a change here. Let's just start at the beginning. I to the first equals I equals I. I cubed will always equal negative I, and I to the fourth equals 1. Okay, so if I, for some reason, ask you to simplify I to the 23rd, what does that equal to? Well, that's pretty simple, because what you do is you find out how many times 4 goes into 23, and you put the remainder, if there is one, on the exponent. So 4 goes into 23 5 times, with how many left over? 3. So I to the 23rd power is the same as I cubed, which is negative 1. So I to the 23rd power is I cubed, which is negative I. So that means these are the only ones you have to know. Because if I have I to the 64th power, how many times does 4 go into 64? Once, 4, 2, 6. 16 times, with how many left over? 0 left over. So you get I to the 0 power. I to the 0 power, anything to the 0 power, is 1. So I to the 64th power is equal to just the number 1. So let's just do a couple more. I to the 10th power is I to the 4 goes into 10 twice with 2 left over. Remainder is all we care about. And I squared from up here is negative 1. I to the 14th power. 4 goes into 14 3 times with 2 left over. The answer is negative 1. Alright, so that shouldn't be too difficult for you to get through. Alright, so if we have something like one of the examples here, they give us they give us I to the 40th power, and the book does it way different than me. And 4 goes into 40 10 times with 0 left over, giving you an answer of 1, because anything to the 0 power is 1. They do this roundabout thing where they take I squared to the 20th power. Instead of 40, they make it 2 times 20, and that equals negative 1 to the 20th power, and then that equals 1, because any exponent that's even will make the negative positive and give you 1. And it's just like, why do you do it that way? It's so much easier doing it the way I do it. But one of the reasons I think I try to do things easier is because math was always a struggle for me, and if I can make it easier for you, then I've done my job. If you appreciate the difficult math, well, I guess you're in the wrong class. Alright, so the way that we're going to write a complex number is always in the form of a plus bi. So whenever you get an answer, it needs to be in that form. Now sometimes, let's say we get an answer of 3i. Well, that's still in that form. It's just 0 plus 3i, where a and b are numbers. So if that's the case, then we don't need that. We can just write it as 3i. If I get a number of 4, well, that's the same as 4 plus, how many i's do I have? I don't have any. So it's actually can be written that way if you want to put the plus 0i in there, but normally you don't. You just leave it as a 4. So a plus bi is the correct form to write it in, and when we do some of these other examples, you'll see how that fits. Alright, so if we have 2 plus I, and it's divided by 3 minus 2i, you cannot have an imaginary number in the denominator, just like you can't have a radical in the denominator. So what we're going to do is we are going to multiply the top and bottom by the conjugate. Okay, the conjugate. The conjugate of anything is always two terms separated by a plus or a minus sign. The conjugate is always the same two terms separated by the opposite sign. So we are going to multiply top and bottom by two terms, the 3 and the 2i, but we're going to put a plus there, and 3 plus 2i. Okay, so when we do that, it gets rid of our imaginary number. Okay, so when you multiply by a conjugate, the bottom will always be the first term squared and the second term squared with a minus sign between them. Okay, so 2i times 2i is 4i squared. Alright, now this is the important part. If you remember with that little chart that I gave you, I squared is the same as negative 1. So this becomes 9 plus 4. So that becomes a 13 then for our bottom number when we multiply these two out. So I'm going to erase. I'm probably not going to erase. I'm probably going to have to make disappear, and it won't let me. Okay, so my bottom is going to be, let me just put it down here, 13. When I multiply these two, okay, again, the conjugate, when you multiply by the conjugate, you square the first number, square the last number, and then you put a minus sign between it. But the key to get rid of the conjugate dealing with imaginary is it will make that squared, and that equals negative 1, so the I disappears completely. Now the top is where it gets the pain in the neck because you're doing FOIL. So the first terms, the outside, the inside, and the last. So you multiply the I times 2i and you get 2i squared. Combine, and this I squared turns to a negative 1. So now this becomes a minus 2. So 6 minus 2 is 4. And then we have our plus 7i. We can't do anything with that. The I is kind of like a variable. You can only bring together variables that are common, and we don't have any variables to do that with, so we kind of are stuck there. Alright, so that appears to be a good answer, but it's not in its correct form. It's not in a number plus a number times our imaginary. So what we do in order to make that happen is we split this up. There's our number. There's our number. And there's our I. That is the answer that I want. Alright, let's do one more and then we'll call it quits. So this is example 18. Holy cow, 18. We are getting rid of that I on the bottom because we can't have an I on there, so we have to multiply by its conjugate. And the conjugate of I is negative I. Okay, so this is going to be negative I times, okay, it's times the whole thing. You have to put that in parentheses. It's not I times just one of these, it's I times the whole thing. So we write it like that. And negative I times I is negative I squared. Okay, so let's go ahead and do the top. Negative 7i plus 4i squared. Negative I times 7 is negative 7i. Negative I times negative 4i, two negatives give me a positive. And, whoops, where did that come from? And the I times I is I squared. And that is over negative I squared. Alright, let's take this one piece at a time. Negative 7i plus 4, I squared is negative 1, right? Over minus, and what's I? Negative 1. So I keep the minus there, and then I take the I squared as negative 1. So now I have negative 7i minus 4, because 4 times negative 1 is negative 4, over negative 1 is 1, which I don't even need to show, and I don't need that sign. The only thing I have wrong here is my numbers are switched around. I need an a plus bi, and I have it in bi plus a. So I just have to switch those around. So my number by itself is first, my number with the imaginary part is second. And let's see, is that it? I think that is it for lesson 9.7. Wow, did it in one video. Crazy.